Alright guys, Unit 3, we're looking at data and statistics, moving on to learning targets 2 and 3. So we've talked about scatter plots and just kind of an introduction to them and correlation and maybe a little bit of causation. And now we're gonna look at fitting a linear function to scatter plots. And then with that, interpreting the slope and the y-intercept of that linear fit. So let's first talk about what a regression line. This is the line of best fit or the linear model. We're going to take scatter plots that have a positive or a negative correlation, that have a correlation that we think, okay, this is good enough that we could make it a model. We could make a model for it. We think that husband and wife's ages, like we talked about, we think that they relate enough that we could make a model so that we could maybe make some estimations and some conclusions based on that model. What that is, it's just a line, so like linear stuff that we've been going through, a line drawn through a scatter plot of two variables. The line is chosen so that it comes as close to all the points as possible. Okay, so we're going to go through a couple different ways to look at that. The first what I want to do though is to take a look at this activity online, and this link is right below this video. So will you guys click on it after you watch this? And what it is, it's just a little applet here that you can make your own scatter plot. So if I make a scatter plot here, and I'll try to make a positively associated scatter plot, a pretty strong positive association here. So notice I'm just clicking random points here, and I can see it's made a table of those points for me. And I also could add in my own points if I wanted to, and we might use this later. But what we can do here is we can show a guess line, and then we can move this guess line by taking the purple points. And so what I'm going to do is I'm going to move this point and this point so that I think I'm going to create a line that I think best represents this data. So maybe I need to go up a little bit. I'm going to try to like touch as many of the points as possible, and it's just a guess. So here's what my line is. Okay, it looks like I've made a line that's almost 1x plus 0. But then what's cool about this little applet is you can show the line of best fit. So you can see I was a little off. The purple line was my guess, and the green line is what the computer actually generated to be the line of best fit. And the computer, and we'll go through, the computer and calculators can take and mathematically actually create a line of absolute best fit, which is something you'll learn in like an AP stats class as well. But for now, we're going to estimate a line of best fit just by trying to get as many of the points close to our line as possible. So what I want you to do is take some time here, play around with this, make some lines that go up. You can notice here if I put more scatter plots or more points on my scatter plot, my line will change, and so you can do that. You can add points. Just play around with that a little bit. All right, and then we're going to go on to our note sheet. So on your video note sheet, we made this scatter plot in the LT1 video with the husband's ages and the wife's ages. And so now what we're going to do is we're going to just create a line through there. So I need to draw a line, and don't do this until I am completely done, because chances are I'll change my line. But I need a line in here that best represents these data points. So I have one up here. I want to make sure I'm close to that, but I mostly want to make sure I'm following the trend of these points. So maybe something like that. Maybe something like that. What's tricky about this line though is that you're really going to need to make sure that there's at least one or at least two really nice points on it, okay? And those could be points from your data point. I could have just said, okay, this point and this point. I'm going to make a line through that. But I think there's value in fitting a line and then maybe making sure that you have some nice points. So what I'm going to do is I'm going to make a line. I think this is a pretty good line. I'm feeling good about it. I see I have one nice point right here, and then I have a nice point up there. So I feel good about this line. I'm going to go ahead and make it. Why don't you try to trace it as well? I made a line that goes through the point 66, 69. And my first point was 36, 33. Okay, so why don't you pause the video and make that line there through your points. Okay, and then what we're going to do, so that's learning target 2, is just being able to create that line. Now learning target 3 is to interpret what the slope and the y-intercept of that line mean in terms of the context. Okay, so we're going to have to create an equation from this line. Luckily, we've already done that. We have 2 points. We know how to create a linear equation from 2 points. So my points are 66, 69, and 36, 33. So I'm going to go to another point or another slide here. My points were 66, 69, and actually I'm going to make that my second point. And my first point was 36, 33. Okay, so just as we did in the last unit, x1, y1, x2, y2, I'm going to create a slope for this line. So I'm going to take 69 minus 33 over x2 minus x1, 66 minus 36. So 69 minus 33, that's going to give me 36, right? And then 66 minus 36, that's going to give me 30. So this would be what? 18 over 15. And let's see, that would be 6 over 5, which would be 1.2, 1 1/5, right? 1.2. I'm going to make sure that's the case. So 69 minus 33, let's double check that, yep. And then 36 divided by 30 is going to give us 1.2. Good. Don't want to make a mistake in the video and then have to redo this. So that's my slope, all right? And we'll talk about, well, let's talk about that now. Let's talk about what does that mean in terms of husbands and wife's ages. Well, if we were talking about that for each change in 1, that's 1.2 over 1. So this is a change in men's age, and this is the change in woman or wife's age, right? So for every 1 year a man is older or younger, the difference is 1.2 in his wife's age. Okay, that's kind of how we could say that. So let's continue then and talk about the y-intercept. So if we plug in a point, so we have an equation y equals 1.2 x plus b. Now I'm going to plug in an x and a y. I'll just use my x1, y1. So 33 is going to equal 1.2 times 36 plus b. So 36 times 1.2 is 43.2. So 33 equals 43.2, was it? 3.2 plus b, and we're going to subtract 43.2 from both sides. We're going to get a negative, so this would be negative 10.2, am I correct? Would be b. Make sure they're negative. So 33 minus 43.2, negative 10.2. So my equation is y equals 1.20 x plus a negative, or just minus, I like to say, 10.2. That's my equation, okay? It's a valuable skill, but let's talk about what it actually means. So we don't have an actual 0, 0 here, so if this line continued to, let's say, dot, 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 down to the x and y axis where they actually meet at 0, 0, it would actually go negative, right? It would go negative to negative 10.2, which if you think about it, so that means when the husband's age is 0, the wife's age is negative 10.2. What does that mean? Why? I mean, obviously you don't have a negative age, and obviously no babies are getting married, and so they don't really have wives. But what does that mean? Think about that, and let's bring that to class, because I don't want to give that away here. I think that's a valuable question. So think about that. What does this mean? Write down what you think it means somewhere on this graph, um, and we'll talk about that in class, okay? So that's creating a line of best fit, creating that linear regression, that linear model, line of best fit. We call them a lot of different things, but that's how you do it. Just find a nice line, 2 points on the line, find the slope, find the y-intercept. You guys should be able to do that. The bigger thing in here is being able to talk about how these two variables relate, and that's what we'll do in class. We'll try to really get at that. Before class, I'd like you to create the scatter plot for the number of people and a cost in dollars here. We don't have a lot of information about this, but we'll be able to make some predictions. So create that scatter plot on your note sheet, choose a regression line, and then write an equation for that. Now, I'm going to get on you here a little bit. We've had some trouble with people actually doing the before class problem. This is a lot of work for a before class problem, so you need to do it, get it done so that you don't waste that time at the beginning of a class, okay?